Thank you, and welcome to my presentation. And sorry for the technical delay. Yes, in this presentation we'll talk about microservices, and I will share my experience in different fields. I am a freelance consultant. I do development, I do architecture, and I'm also a co-founder of a startup called Linked Farm. So where I do distributed systems. Why? Because I work with different societies, and they have different needs and different applications as well. So there I encounter a lot of problems with distributed systems. I will share some of them in this presentation. So we also saw a lot of a few approaches in the previous presentations. How to do software development, so you can jump into the serverless track, or you can do domain-driven design. That's another approach. And we heard kind of success stories and some challenges in both directions. In this presentation, I wanted to put a lot of technical stuff in the beginning, but then I took it away. I want to concentrate a little bit on the other things than the technical aspects when you do development and when you think about designing systems. So in the beginning, we start nicely, relaxed. We quite relaxed because we just have one system, one database. We don't have anything. We sit there, it's cool and relaxed. But all of a sudden, the life gets boring, and we see all those technologies, and they're super cool. We have microservices. We have serverless, you have functions, you have databases, you have the cloud, and everything is super easy. With a matter of minutes, you can deploy your servers. I mean, you can start up servers, and we feel powerful, and we go there without thinking, and all of a sudden we have a mess. I mean, a big mess, because we cannot really control all those things. We're not ready. We're not ready to distribute our databases. We're not ready to distribute our compute functions. I mean, we're not ready to distribute our logic, essentially. Distributed systems are quite difficult, and we have to read a lot before you go there. But let's first see why do we need that? Why we want to have a fancy design? What's the need of it? And there's several reasons, for example, to have that. And we see it. It's a challenge. It's nice. It's cool, and it fixes a lot of issues. But we just read the pros of all those things. They say it's easier to debug and modify and add features on a smaller components. We limit the problem scope, and you concentrate on the business aspect of the things. You can use with different teams, different languages. You can deploy services independently, scale, and scale for availability as well. But let's dig deep inside them. So the first one, okay, it's cool, but what is this about? It's I've been doing this as well, and what is this about? You see a new technology, and you don't think about the business problem. You think about how the technology can fit this business problem. In fact, how this business problem can fit in the technology is the other way around. And we tend to over-engineer. I was there. I was doing that. It's kind of an illness. And easier to debug, modify, and add features. Well, you see microservices as a smaller piece of code, and that's why you think it's easier to debug. That's why it's easier to add more features and speak to the business and modify, because it's smaller. But how is that new? How this comes with microservices? Wasn't it there before? I mean, it's a good practices in software design. Another thing is we concentrate on the business capabilities of what the business actually needs. And again, how is this new? In fact, doesn't come with microservices. It's a general thing in good software development and design. One thing on the previous one, easier to debug, and modify and add features on the smaller components, but at the end, you're interested also in the whole system. So imagine, is it really easy to debug the whole system, which is separated in multiple components? How do you trace the communication between those components? How you aggregate all the logs, all the debug, how you dig into those logs? There are questions which sometimes we don't ask ourselves because before going in there. Use different technologies, languages, database technologies, etc. NoSQL, SQL databases. So there's a lot of articles about how this is cool. I mean, because different teams they work with Node. Some people work with Java, some with Ruby. Who knows what? And they like those languages, their frameworks, etc. So you give them the ability to write in their own language and framework. That is cool. We have it to some extent without microservices in our monoliths as well. One interesting thing is deploy services independently. That's a nice one. I mean, you cannot do this with a monolith. Really, you cannot just deploy one feature. You have to package and deploy the whole thing. It causes problems sometimes. Another interesting thing is to scale independently. Well, it's quite handy. It's true, but you have to ask. I mean, and it's also, this is not a technical question. Do you need to scale or not? It's a business question, because business knows better what feature will need scaling. I mean, you should ask the business. And do you actually need scaling? Most of the cases, not really that much scaling. I mean, you're not, unless you Google or Twitter or Facebook, or Netflix, but most of us aren't. So we deal with smaller types of problems. We don't really need that. But yeah, it's handy. Improve availability. That's a nice one, and most of us probably need that. Of course, not all the time, not 24/7 availability, but relatively good availability. And this helps. It helps at a lower cost, because you know which services are fragile, which parts of the monolith are fragile, so you can kind of separate them easily, and you can put up a redundancy on those features. I mean, being that just calculations or databases, etc. So some of the things we might need, it really comes with. I mean, you have to separate your monolith to do that. Some are just in our vision, and there's another thing which was not mentioned to you. Another reason why you need microservices or distributed systems. Why? Because you essentially deal with different societies, with different software and applications, and you cannot combine those. You didn't acquire the companies of those, so you cannot put them into your system. So you need to cope with those. And you have no choice. And you have to make them interoperate, and you have to, you're essentially going in the distributed world. And to go there, you have to know a few things from the past, because we have to see what are microservices actually. What is it so fancy about? So that's a Martin Fowler explanation. I will not read it, or if you can not read it, it's a service-oriented architecture. Is a very broad term and practically meaningless. Microservices is a subset of SOA, with the value being that allows us to put a label on this useful subset of SOA terminology. And he defines a few other aspects of microservices, a few of them which I already shown. But the thing is that service-oriented architecture, there was client-server as concept before, and the guy invented SOA, didn't use clients a server just because of the same reason. So it's actually so done right, or specific type of so depends how you see service-oriented architecture. And in fact, what are distributed systems? This is a subject which is very interesting to dig into in the academic world. In fact, not in the software development world. In the academic world, because we software developers are not that educated. We don't read too much of academic stuff, at least myself. We like cool things. We like to develop things. We have to have something which is really working. So, and we don't think in depth. And when the problem comes, okay, well, there's a big a problem of consistency, etc. Well, this is already known. So there is this a definition of what a distributed system is from the 70s. It's a collection of independent computers, appears to be as a single coherent system. So yeah, it's a coherent single coherent system to the end users. Essentially, that's a monolith. I mean, it's one system, but it's a modular monolith. You can translate it like this. Another very nice a definition of this distributed system is one in which a failure of a computer you didn't even know exists can render your own computer unusable, meaning that you can crash your system. That's not fault tolerant, of course, this type of design architecture, but that happens in distributed system. It's dangerous, not nice. And these studies are made back in the 70s, in the 60s even. Let's see what is object-oriented programming. And Alan Kay, who invented Smalltalk, in fact, I thought of objects being like biological cells or individual computers on the network, only able to communicate with messages. Do we see object-oriented programming like that now? I don't think so. But it's like microservices definition to me, right? Yeah, so Smalltalk, this was in the 70s. And there is the actor model also then. So Carl Hewitt, who invented the actor model, and there are many papers about the actor model. What actor model is autonomous objects which communicate with messages. That's what actors are. So it was invented already there. It was used already there. We have it there, and there is a lot of articles about it. Just a quick peek what an actor is. And these are actors. Those circles, they're actors. What an actor have is a mailbox. What an actor can do is receive and act on the messages. What an actor can do is send messages. And what an actor can do is create, spin up more actors. These are the few characteristics of an actor. It's a microservice design in a way, right? So we have a lot of stuff which has been already studied thoroughly. So we have to read, we have to learn from the past and see what people has already invented. So how do we switch to microservices? Let's say we have a monolith, and for some of the reasons we might want to switch to microservices. So how do we do that? You don't start creating a microservices kind of architecture. You create your monolith step by step and divide it when you need it. I mean, it's much easier, in fact. One process for all services. It's super simple. You don't have network partitioning there. You don't need to handle timeouts. You don't have to think about those things. It's very easy to concentrate on the business logic. Then you separate the process, because one process use up the memory of all the other processes. Okay, this is a bad one. But we separate is a service per process. I mean, operating system process, and that's cool. You need more separation as time comes, and you start to use containers. and eventually you start to use nodes per service, and yeah, use container managers, etc. And this is how I actually end up doing after a bit of going around different serverless approaches and other infrastructure as a service approaches. So this is in my opinion a good way to start, a good way to develop, debug, and you process fast. It's also part of this idea to bring up value fast. I mean, you don't think of the big architecture. You bring up value as soon as possible to the business, and the business can react, because the architecture you have already created, the business will not need any, because business changed their mind a lot. So, and it is possible without a big refactoring. There are tools to do that. There are tools to, I mean, there are tools to do modular design and modular development without big refactoring. At the end, you have to think in advance. You have to design it. That's the only thing, yeah. And you have, it depends really on the problem you solve. There is no silver bullet. There is no an article who tells you what to do. It depends on your business case. This is very, very, very important. So before you start, you have to define, you have to make your design, you have to define your domain. So we had a very nice talk about domain-driven design. I don't know who followed that, but it's a very, very good approach, in fact, to create software. Define your subdomains and define your boundaries of your components. I mean, where your component ends and where the other one starts. How those components interface, what type of messages and events they share. This doesn't exclude CRUD, for example. A message is a post message or a get message. It doesn't really matter. It's a basic interface. You choose the technologies, the protocols, and the languages, and this depends again on the business case, on the teams you're working with, in the organization you're working with. For example, I use a lot, let's say, a Google Cloud. I use infrastructure from DigitalOcean, for example. As a customer, I use Azure. Why? Because it makes sense for them to use Azure. Everything else is Microsoft. So you have to really think about that. It's not one is better than the other. That's the domain-driven design. It's a book of Eric Evans. It's super old stuff. It started around year 2000. So there's a lot of stuff about it, a lot of experience already, and there's some of the concepts of DDD. What is an aggregate? And that's basically an associated group of objects. You can see it as a tree, as a JSON tree, for example. An aggregate root is your interface. What the entity which kind of manages this aggregate. Nobody else can do that, and that reassure you about a consistency and such things. You have a value object, which is just an immutable container of data, and then you have an entity which can be referred by an ID. Similarly, like a URI in the semantic web. You have a bounded context, and that's an isolated context. That's basically the language boundary, how your business communicates, and that communication is essential to grab when you design your software. And then you have a saga. It's very important. It's a process manager. A lot of people have done BPMs. It's a big thing. It's a very valuable thing, but it has to be also kind of coordinated, not to grow too big, because it can the complexity can be super big, and not it can become a monolith, a mess, a spaghetti. One thing, monolith is not a spaghetti code. It's different thing. Spaghetti code is bad development. The monolith is just the way you do your application. So that's an example of how you define your domains and your bounded context. So you speak to the business, you see how your organization is basically structured, and you come up with different bounded contexts. For example, marketing, accountancy, e-shop, whatever. CRM kind of handling, and then when you dig inside those bounded contexts, you find your aggregate and your aggregate root, and that's your interface to the outside world where you have another aggregate root. And these things has to be clear. This is your data and this is your interfaces, how the data is communicating. This is very important to define before everything, because this will define what tools and what technologies and the structure of your application. So let's continue with interfaces. So we define our business. We have to see where we go with microservices. Okay, we see microservices and you have to do REST. Most of the things, in fact, they're not REST. They just HTTP APIs over HTTP. REST is very well defined by Roy Fielding back in the year 2000, and it's very difficult to implement fully, but it's also doesn't make sense for a particular use case to be implemented that much as Roy defined it. And the reason is that it's made for the web. It's made too generic, and businesses, they need specific things. But let's see. One of the things is REST and over HTTP, but it makes a lot of sense to use WebSockets. It's more performant. Service and events. I mean, that's a kind of, if you need a WebSocket, but only to receive events. You can do RPC, and RPC is not bad. On the contrary, it's really, really good and much more performant than REST. So if you, the difference between here and here, you have less coupling here, more coupling there, but that's not bad if you're in contact with those development teams, and it's really defining your protocol to communication is similar as your communication is with the people developing or being the owner of these products. So it's kind of much there. So gRPC from Google is really good, and you can also use event bus. Event bus is widely used, and it's very, very practical as well for internal communication. So I can talk a lot about REST and RPC, but we don't have time. It's a lot of talks, and it's a lot of talks. So then you have to have a queries. We have Sparkle. Who heard of Sparkle, in fact? And who heard of GraphQL? Okay, and that's a bad thing, because Sparkle is really good. It's even better than a GraphQL but it's for the semantic web. It's not that known. It's more or less in the academic world. Gremlin is a query language for graphs, for graph database. And Tinkerpop from Apache is one implementation of a graph. One implementation of Gremlin. And GraphQL is a cool thing as well. GraphQL is a really, really good cool thing. It's by no means, but it's far from REST. It can be based on REST. It's not a replacement of REST. It's totally different things. REST and GraphQL. You use it only for queries. Interfaces now. So we define. Let's talk about the schemas, the data we transmit, the type of events we change for any of those type of protocols or technologies we use. Protobuffer. A protobuffer is quite nice because it's optimal, because it's much smaller than, for example, XML and JSON. But these things, you need to define them. So schemas, they exist for protobuffer. Well, it has a schema within itself. In a way, XML schema, you need it to define, for example, with all the Microsoft solutions, you need to do that. And it's nice because you need to know what your data will look like. When we went to JSON, we exchanged data without schemas. Nobody did schemas in JSON, and still a lot of people do not do. Who heard of JSON schema? Yeah, quite a few people. Before I've seen less hands, but JSON schema is really, really good thing, and people should use that to define their data. And it's really good for testing as well, because you can generate your models and flood your APIs. Any other type of interface description language. So you have also VSDL for services. service language, and then you have the web application one. You have the SOAP one. You have also Swagger and Open API. Who uses Swagger and Open API? That's really, really good. It really helps for testing as well. It really helps to document stuff. You can auto-generate Swagger. From Swagger, you can auto-generate your client or parts of the server. And that's a really, really nice thing. And these are more into full hypermedia type of interfaces. This is a more broad. We're going to real REST here. Hydra, Helm, JSON's hyperschema. So what this thing define is how, what is, to some extent, what those things define, but these are more or less dynamic. It's the principle follow your node. So when you develop your client, you don't know prior to the runtime, for example, what services are available and how you will going to call those services. And these languages can show you that in runtime. But this involves a lot of development in the client. This involves smart clients, and almost nobody from the industry does it because it's a little bit hard, and business doesn't like to spend time on those things. Let's talk a little bit about frameworks that we'll use, and I will be there fast. So we have a lot of them. Akka is really good if you have Akka is based on the actor model. It's really, really good if you work with Scala. We all know those. Those are good. Drupal is also an application development framework. Drupal is based on a lot of the libraries on Symfony now, and you can do really nice microservices around Drupal. Spring is really nice. I use it a lot as well, and I use Vert.x quite a lot. So Vert.x is similar to Akka, light version of Akka, but it's a polyglot type of framework. So it has vertices, verticals, which are the actors in Vert.x. And if event bus, the event bus is naturally there, and it's implemented by default with Hazelcast, but you can put Kafka or whatever you want there. So it's really, really good and really easy to start with. A lot of tutorials are there as well. For data storage, we use SQL, we use NoSQL, use Event Store. Event Store is used when you do event sourcing. And that's really good. You can do it with both approaches, for example, but it's kind of different because you apply different things there. You store your events, you have to design your events. Well, here you define your schemas here partially. And again, those things is defined by the business case. You don't want to make a joint with two NoSQL tables, with two NoSQL storages is super difficult, and SQL has this already. So think in advance what you will need to execute on a specific aggregate, if we use the DDD terms. And all the managed cloud DBs, I use a lot Firebase, and now Firestore, I think, is the new one of Google. And there are many others. So so hosting. Some data center, you can go in Azure. For my personal projects, I don't do there, but most of the clients that I work with, they use Azure. AWS is very, very flexible, but super difficult to figure out the pricing there. You have the Google Cloud platform. It's a little bit easier, a lot very flexible as well. This is the IBM Bluemix. It's a very nice one. I like it a lot. It's not that extended as the others. And you have Heroku. It's like more managed, so you can just push your application, and it does most of the thing for you. And DigitalOcean, it's a pure. It gives you droplets. It gives you boxes where you put your applications. It's super nice to manage. And if you are a startup, you don't need a lot of management stuff. You can go there. I use it a lot. And it has super nice API. You can really automate stuff to pop up a different droplets, they call their instances. And it works with Docker as well, with Docker machine. Super nice as well. So yeah, deployment. How you deploy? With containers, use containers, or you don't use containers. So at first I didn't use containers, but then it was natural that it was easier. It was just easier. It was super simple. And later, you figure out that you have a bit of a container. So how do you manage those? I mean, really easily. You have Kubernetes, you have Docker Swarm, you have OpenShift, and you have Mesos and DCOS, and you have the cloud ones of Google, of Amazon, and of Azure. The thing is that I went with Docker Swarm with the future probably to go to Kubernetes or to Mesos. With Docker Swarm, why? Because Docker Swarm is super easy to set up. I mean, in a matter of minutes, literally 5 minutes, you create your cluster, and you join services there, and it's you join workers and you put up services. It's super easy, and it works natively. Of course, it's Docker, so it works with the API of Docker. It's very nice. And Kubernetes is a very nice one as well, but it involves a little bit more setup. So if you don't need it, if you don't need a lot of management, you can use Docker Swarm. It's very nice, and it can be managed as well on top with Mesos. Which we work also with Kubernetes, but this one is a little bit bigger. It manages your whole data center. The idea is to have a distributed data center, like we have a computer, and to manage your whole resources there. And of course, you can use the cloud ones, but you kind of stick to particular setup there. Monitoring and logging, very important thing. Probably the most important thing before you go to production, and before that, I mean, for testing and continuing with your development. So, one which is really good is Prometheus. Another one you can just use the Elk Stack, Elasticsearch, Logstash, and Kibana. It's very nice. I use it for a long time now. Prometheus I don't really use kind of in production. And you can use anything else, but you have to have monitoring and logging. I mean, whatever it is, if it's a simple flat file you read or search, whatever, you have to have a monitoring and logging, because it's a mess out there if the things scale automatically and independently. And then finally, what I got is, this is a little bit of the, also a little bit what my design is. Of the systems that I do, a part of it. So we have different interfaces. You have an API gateway, which is also a vertical. It's an actor which delegates stuff, and you have different services with different data storage and persistent with different caching mechanisms. And they're independent, they can scale independently, and it's quite nice. And I have Docker Swarm currently, as I said, it's more or less like that. In fact, I have one manager just right now. It's good to have 3 at least. And then you have the workers, and then you put up stuff there. This is I have a small script which you can spin and join containers and join workers really easily to the cluster. I host this on DigitalOcean now. I use Firebase a lot as well. I use object stores as well for different purposes, but it's very nice it's very easy to link them, in fact, and to work with that. Well, some final takeaways. So be pragmatic. Do what your business needs. In fact, do not engineer stuff because it's interesting, but keep your eyes open. Try out stuff, because technology can provoke business to think of new ideas. You have to think why you need to go distributed. Distributed is complicated. You don't go there if you don't need it. For example, before starting to do that, do your monolith modular. It's super. It's not easy. It's super easy to move from modular monolith to microservices. You just split the packaging. As simple as that. That's how I did it. In fact, split the packaging and put my verticals in another package, and put the package in another container, and there you go. It's trivial. Actor model is very useful. It's practically what you need for microservices. Think about it. DDD as well. You design your things. DDD is about microservices. BDD is behavior-driven development. This is also very, very good because it helps DDD to evolve. It also talks about the ubiquitous language you need between the technology departments and the business and the whole organization, in fact. And it's really good for to apply real good TDD. Test-driven development. Event sourcing can be handy, but it can be tricky because it's another type of concept. You don't have, it's again another talk, but it's really nice in some cases if you do accounting or if you need an audit log, if you need tracking as you do of packages going around or anything else. Look it up. Pay attention how you design your events, your messages, your interfaces. It's very important. Sometimes to outside world you cannot change those really easily. These are your contracts to the outside world. Eventual consistency don't need to be really consistent. This is not too bad. I think most of us don't really need that. Sharding can help that because you can just store things in shards so they kind of don't conflict. There's no conflict at the end. So think about sharding as well. And design with fault tolerance. This is very important. You cannot guarantee that another microservice or service, let's call them just services, because they are another microservice, another service is not there, is there. We cannot guarantee that. So you have to handle that. And that's a really tricky part when you go distributed. And make sure you have monitoring in place. Very important thing. I connect my monitoring with Slack as well. So we have some problem. I receive Slack messages. It's really cool. If I want to deep inside it, I use Kibana, for example, and there you go. And that's it basically. And thank you. And thank you once again. And cheers. Na zdrowie. Thank you.